All right, hello everyone. My name is Tim NeCamp, and I'm a PhD student in the Department of Statistics at University of Michigan. And today I'm going to be talking about how we develop some mobile health interventions to improve mood, activity, and sleep for medical interns with the intern health study. And this is kind of related to, if you went to Jenko's talk yesterday, it's the same study, the intern health study, but the newest iteration of that study. So this work is in collaboration with Srijan Sen, who's the PI of this intern health study, my advisor Jenko Wu, Maureen Walton, who's a behavioral scientist, Ambush Tawari, Elna Frank, and Yu Feng. And so just a quick overview of what I'm going to be talking about. I'm going to first give background into the intern health study and the trial that we're running, and talk about the trial design specifically. And the trial is a micro-randomized trial, which is a trial useful for developing mobile health interventions. I'm going to also focus a little bit on missing data issues. The reason I'm going to talk about missing data is because it's been something that's come up in this workshop a few different times. And I think it's a problem that is recurring in mobile health. So I want to talk about some issues we've had in our study and then also propose kind of a heuristic solution, but then I guess the goal is to maybe foster collaboration or future discussions about solutions to missing data problems in mobile health. I'm going to talk about the results of our study, and then I'm also just going to conclude and talk about future work. Okay, so the intern health study is a mobile health study where data is going to be collected on the phone and wearables, and the data is collected for medical interns. Why do we focus on medical interns? So first, medical interns are doctors, so they just finished their 4 years of med school, and they're in their first year of residency. So each year that this study goes on, it's a new group, a new cohort of medical interns. They're in their first year of residency. This is a time period that's known to be pretty stressful, highly stressful. They're making a lot of medical decisions for the first time. They're working really long hours. They're not getting a lot of sleep. So it's a very stressful time, and you can kind of see from this figure here that this is before the internship, and then this is during the internship. This is the prevalence of depression, the percentage of the cohort that's depressed. And you see that obviously huge jump once the internship starts. So unfortunately for these interns, they are a very stressed and highly depressed population, and it makes them kind of perfect candidates for understanding depression and understanding stress and how they relate to each other. So what do we do for these medical interns? First off, we use mobile devices to collect data on them. So there's 2,111 medical interns in the 2018 study, which goes from basically July of 2018 to July of 2019. And we use wearables, so specifically a Fitbit, to collect information on their step count, their activity, their heart rate, and their sleep data. So we know how much they're sleeping and different sleep stage data. We use their phone to collect this self-reported mood outcome. So you see here on the right, this is a questionnaire that we ask them every day about their mood. It's just a quick sliding on their thumb on a scale from 1 to 10. What was your mood, or how was your mood today? 1 being low, 10 being high. And that's done every day, like I said. And then we also collect a survey every 3 months and at baseline, which asks baseline questions, like previous history of depression, or whether or not they have children, their gender, et cetera. But it also asks this personal health questionnaire, which is a patient health questionnaire rather, not personal. It's a 9-question survey that is kind of like a validated measure of depression. So if your score is bigger than 10, you're considered depressed, lower than 10, not. So it's kind of a more validated measure, but a little bit more intensive to collect because it's 9 questions. So we do this about every 3 months through the study. Okay. And obviously this talk maybe should be around 45 minutes, so I have time for questions, and I think it's more useful to ask questions during each of the parts, so feel free to stop me at any time. So we have this observational data that we're collecting, and we've kind of been collecting this for several years now. Jenko talked about the 2015 cohort where we collected similar data. But in the 2018 trial, or 2018 study, we also are intervening on these medical interns. And specifically, we want to develop mobile health interventions that can hopefully inspire some type of positive behavior change to help them during their internship year, to help them cope with the stress, to help them maintain good habits during their internship year. And specifically, we're focusing on 3 different categories of behavior change. One is just maintaining a positive mood, so mood type interventions. Second is maintaining healthy sleep habits, so getting at least 6 to 8 hours of sleep every night. And then the last one is having them stay physically active. And the reason why we focus on these 3, mood obviously is strongly related to depression, but the other 2 are also known to have strong correlations and relationships with depression and mood. So the hope is maybe we can affect their mood, or maybe we can affect their sleep and activity, which in turn will affect and improve or lower their depression rates. So that's the ultimate goal. And we're not sure which of these is best to intervene on, which, maybe they can't just change their mood magically, but we can change their sleep, which eventually will change their mood. So we're not sure ahead of time which of these would be the best thing to intervene on to help them cope with the internship year. So the first intervention component that's new, this is a component that's not going to be randomized or experimented on, but just provided to all of the interns, is just a data dashboard where we basically provide summary statistics of their previous mood, previous sleep, and previous steps. It's known that self-monitoring can potentially help someone maintain positive behavior or change their behavior. So this is kind of like a self-monitoring type of intervention, but we don't experiment on this. We just provide it to everybody. That's an example of what the dashboard looks like. Okay, and then the second thing that we're going to do, and the thing that is of most interest in this study, is we're going to be sending push notifications, which is like what you see here on the screen, just a notification to your phone. And we're going to send different kinds of push notifications. The push notifications may be of 3 different categories. So they may be about your mood, they may be about your activity, they may be about your sleep, which again is to help try to inspire positive behavior on those 3 categories. And they also might be either a life insight, which is a data-driven message, so it has their data in the message itself, or it might be a tip, which is just general advice, not based off of their data. And this is an example of a mood message that is a tip, so it says, remember that show you binge watched during med school, try rewatching an episode after a stressful day. So this would be an example of something that's maybe trying to improve their mood, and it's not based on their data, so that makes it a tip. Here are just 6 different examples of the 6 different possible messages given that 2x3 type factors. I can just let you read them or read a subset of them. So you can kind of see the difference between the life insights, which has their data in it, versus the tips, and you see how the sleep is targeting their sleep, activity is about their activity, or mood messages are just generally about their mood. Okay. So this is the intervention. And given these types of messages and their different buckets, we have research questions about them that we hope to answer with a trial. So this first main question that we have is about how do these different categories of messages affect mood, activity, and sleep. So do mood messages positively impact their mood? Do activity messages positively impact their activity? And do sleep messages positively impact their sleep in the short term? So does it, like, maybe sleep messages affect their sleep the next day? We also have questions about how this effect changes based off of past data. So this is kind of like a moderator type of question. So we want to know, basically, do these effects change based off of their previous mood, activity, or sleep? So for example, we might find that if someone has low activity the day before, then activity messages really help them. But if they had high activity the day before, then activity messages don't really help them at all. And the reason why we want to answer that question is because that can eventually inform how to tailor the sending of these messages. It can inform, maybe you only send messages to that case to people with low activity, you don't send anything to people with high activity. Or maybe you send something else to people with high activity. So by figuring out how the effects of messages change based off past data, it tells you basically how you should change sending the messages based off of that past data as well. We also have a question about, how do the life insights compare to the tips, data-driven versus not. in the short term. And then we have this kind of distal long-term outcome about just messages in general affecting their long-term mental health outcomes. So this is kind of like if you can imagine kind of like a randomized control trial. If we give some interns messages throughout the whole internship year, throughout some of the internship year and some interns not, then maybe there's a difference in their depression rates between the group that got messages, the group that didn't. So this is kind of like a long-term mental health outcome effect. And that's going to be, again, measured by the PHQ-9, the one that we measure every 3 months or so. So these are the main research questions. So to answer these questions, we use the trial design that is pretty well suited for both mobile health interventions and answering questions about short-term effects and moderators, and that's the micro-randomized trial. So the micro-randomized trial, I know obviously Susan has been talking about the micro-randomized trial over the past couple weeks, and I know other people have as well. But just in case you're not familiar, I think the biggest difference between a micro-randomized trial and a randomized control trial is that in a randomized control trial, which everyone is pretty familiar with, you randomize everybody at the beginning. Maybe these interns get randomized to getting a message, these interns don't get messages, and then that's it. That's the only randomization. In a micro-randomized trial, you continually randomize a person basically every time they could possibly get messages. So if I'm an intern in the study, I get randomized, maybe every day I get a message, I get randomized like with a 50-50 chance of possibly getting a message. That would be an example, but I'm getting randomized basically multiple times to get a message or not, or to get a certain type of message or not. So randomizing people multiple times throughout the trial. What is a big advantage and why are we running a micro-randomized trial in this setting? It's specifically because of our research questions that we have about those messages. So first thing is a micro-randomized trial allows you to kind of estimate short-term effects. So by randomizing somebody every day, I can see like, oh, today I gave you a mood message. How does that affect your mood to maybe the next day compared to not getting any message? So it helps you answer questions about short-term effects, which is what we're interested in. And then the second advantage is it helps you understand and learn real-time moderators. So I can see basically how does the effect of a certain type of message change based off of data collected throughout the trial. So like I said before, maybe activity messages perform better for someone with low activity in the previous day. That's a real-time moderator, that daily activity, and I can see how to tailor and how to send messages differently based off of that data being collected all throughout the trial. And by re-randomizing you, I can basically detect that effect. If I only randomize people one time at the beginning, I wouldn't be able to assess those moderators. So because our questions are about short-term effects and about these real-time moderators, the micro-randomized trial is a perfect trial to run to answer those questions. So this is the randomization scheme. I'm going to go through it quite slowly. I'm going to go through it pretty slowly and go through kind of each component, but this is kind of the overall scheme. So we do some initial randomization, which is like a randomized control trial type randomization, where we randomize people to getting messages or not. And then within the group that's getting messages, every week we do a randomization to a different category of message. Either it's a week of sleep messages, mood messages, activity messages, or no message. And then within that week, if let's say, for example, I'm in a sleep message week, then every day, I don't get sleep messages every day of that week. Every day with a 50-50 chance, I have a probability of getting a sleep message or not. So roughly on the sleep message weeks, roughly half the time half the days I'm going to get a message, and half the days I'm getting no message. And if I am getting a message, then I'm going to switch it deterministically, just switching back and forth between life insights and tips. So I'll talk about each of those randomizations and components specifically in a second. Just real quick for the trial, like I said before, there's about 2,000 people in this trial under this kind of randomization scheme. The trial starts on June 30th, which is usually the start of the internship date, and ends December 31st, so it's a 6-month trial. And usually the messages are sent every day at the same time at 3 p.m. And the mood scores, which is the daily outcome that we're sometimes interested in, is measured at 8 p.m. Yeah.
Why do you randomize every week to a single type of possibility? You don't consider every day I randomize.
Right. Yeah. The main reason is like the behavioral scientist, Maureen Walton, on the trial, she thought that So if I send you a sleep message today and then an activity message tomorrow, just getting that sleep message, you're in your internship, you're really busy at the hospital, maybe you haven't gotten enough messages, you don't have enough time to actually change your sleep that night. So maybe you need to see like a series of sleep messages in order to like inspire that behavior. So it's like she basically thought that like just sending one message one day won't give them enough time to just change their behavior. So if we send several messages of the same type or same category over a week, then we can actually give them time to adjust their schedule and actually act on the messages. Yeah. So just going through the different randomizations. The first one, like I said, is kind of like your normal randomized controlled trial, A/B test type randomization, where we randomize 75% of the participants to getting messages at all during the internship versus 25% don't get any messages at all. What's the point of doing this initial randomization? It's to kind of measure the effect overall of getting messages on their long-term mental health outcome measured by the personal health questionnaire. So I can compare the 3/4 group to the 1/4 group on their 3-month PHQ-9 score and see if the messages had an effect or didn't overall. So that's the pre-internship randomization. Then we have this weekly message category randomization. And kind of like I said, the reason we do it at the weekly level instead of at the daily level was because we want to give them several messages of one category in a row so that way they have time to react and time to change their behavior. And the point of doing this randomization, so this is like the first micro-level randomization at the weekly level. The point of doing this randomization is to answer questions in the short term about these short-term effects. So one question we might have is about like, does getting a week's worth of mood messages affect your daily average mood for that week compared to no message? And by doing this weekly level randomization, I can answer that question. And similarly for activity or similarly for sleep, we can answer those questions about just their general effect on the week's worth of mood, activity, or sleep. We can also answer this question about the moderators, about how does this effect change based off past data, which is, again, one of the advantages of doing the micro-level randomization. So I can answer the question of do sleep messages affect people differently if they had low sleep versus high sleep? So that's this question here. How do the effects of different categories change based off of maybe their previous sleep? So maybe sleep messages only work well for people with low sleep, for example. So that's the weekly level, which is kind of like the main randomization. And then we have this daily level randomization where they have a 50-50 chance of getting, if they're in a week where they're getting messages, one of these top 3 weeks, then they have a 50-50 chance of getting a message at a daily level. And then if they are getting a message, it alternates deterministically between the life insights and the tips. Why do we do this? I think the main reason actually is less research-driven and more, I guess, just like behavioral science-driven and mobile health science-driven, and this to prevent burden and loss of engagement. So if we send them a message every day of that week, it might be overly burdensome, especially because these interns have really, really busy schedules. So, getting a sleep message every day reminding you to get more sleep might be frustrating. So we instead do it about half the time. And then also, one advantage of doing this kind of randomization is we can actually look at the treatment effects of life insights compared to no message because of this randomization here. So it's a little bit causally tricky to argue, but because of this deterministic alternation between life insights and tips, but you can compare life insights to no message here, and you can actually compare tips to no message here because of this randomization. So that helps us answer the question of comparing life insights to no message or tips to no message. Okay. Yeah. Yeah. So, I mean, the advantage of this is you can look at any outcome after this initial randomization. So if let's say they're randomized every Sunday to a different category, you could look at the effects on the mood, the average mood for the subsequent week. So after that initial randomization, so during the week that they're getting mood messages, you could also look at it maybe like a lagged effect. So you could look at its effect on the following week's mood. The outcome that we focus on in this one is the current week's mood. So I'm randomized on Sunday, then I look at your average weekly mood from Sunday through the next Saturday, I guess. So we do it the same week that they're getting the messages. Similarly with sleep and activity, we look at their average daily sleep for the week that they're getting sleep messages compared to weeks where they got no message, their average daily sleep for the week. Okay. And then just some information about the trial. So the data collection actually starts in April. They collect some pre-internship type data, like to get ideas of their pre-internship mood, pre-internship sleep, pre-internship activity, but then the actual interventions are being sent June 30th, which is the start of the internship, to December 31st. And then once again, this is the sample size. We have about 2,000 interns in the trial. So because of that initial randomization, around 1,500 are getting messages. Else all over, actually. Yeah, so it's all over the US.
All over the US.
Yeah. So we collect that information at baseline, but we know which of the hospitals that they're at. Yeah.
Is it under market?
She's involved in this. Yeah, the main PI is Srijan Sen, who is like one of Margaret's old students, but no, he's. Yeah. I think for now, so this intern health study has basically been going on for over 10 years, and it's grown and grown each year. And this randomization is now just on US interns, but they've started basically observational data collection, non-intervention data collection for interns in China, in Shanghai. I don't know. Yeah, I'm not sure. I don't know, it's pretty pervasive, I think. Like, I know some med students that they get the email in their 4th year, like, hey, do you want to be a part of the study? I think it's like sent out to almost all med. Right, yeah. Yeah, I think it's promoted like amongst the interns, yeah. I mean, I think they have to get approval from the hospitals, right? Yeah, but yeah. Okay. Yeah, and it's a pretty large study, right? 2,000 people in a micro-randomized trial. It's quite large. So kind of related to that, we do have a large sample size, but because of this large sample size, we actually have some pretty big missing data issues that I said I kind of wanted to talk about for a bit. One of the big reasons we have some missing data issues in this data set is because one of our primary outcomes, which is their mood, is a self-reported outcome, and it's known, self-reported outcomes probably have more missingness than passively collected data. But even if it was just our only outcome of interest was their step count, there's still a large amount of missingness with the Fitbit data, basically caused from people not wearing their Fitbits, maybe not wearing their Fitbits at night, maybe like wearing their Fitbits at the beginning of the study, but then dropping off because it's a 6-month study. So, I mean, this missing data issue, yes, is a problem in our data set, but I think it's a problem that's kind of pervasive through a lot of mobile health studies. If you have EMA or even if you have passively collected data. I'm going to talk about our solution to dealing with missingness, to analyze the micro-randomized trial data. It's kind of a heuristic, but I think it makes sense. But I'm happy to talk more. People have like known citations or references to point me to. I'm happy to look into those too. So just to give you an idea of the missingness, here is mood, sleep, and steps, and the percentage non-missing at every day. So you kind of see, like at the beginning of the internship, we're looking pretty good. Mood percentage non-missing is around 80%. Activity, their step count's pretty large. Sleep's around 75, 80. But as the internship progresses, you see, people become less willing to wear their Fitbits and less willing to report their mood, with non-missingness in like the 60 to 70% range. Right, so this is problematic, partially related to the long study, and partially related to the fact that we have 2,000 people in our study, so we kind of increased our sample size by a lot, but it's really hard to make sure and monitor that all these people are constantly wearing their Fitbits or constantly reporting their mood. So we've kind of sacrificed missingness for the cost of a larger sample size. Luckily, we're not, this level of missingness, like 60%, might be troublesome. Luckily, we're not too awfully worried, because if you remember, our outcome of interest is weekly level mood, sleep, and activity, weekly averages. So though maybe they're missing like 40% of their mood scores in the final weeks, luckily when we take a weekly average, it'll be based off of them having 3 or 4 measurements for that week, and then maybe the other 3 or 4 are going to be imputed. So that gives us a little bit of more stability when we do the imputation, that we're doing kind of a weekly level average. So all the weekly level averages will hopefully include some non-missing data. But just to show that so since we're taking weekly averages, this is the number of mood scores per week. So 7 here would mean that this is the percentage of the weeks where interns put in all of their mood scores. So the average would be over 7 non-missing data points. So that happens about like 7 to 8% of the time. And you kind of see what I was talking about before. So when we do our weekly averages, it's going to be based off of around 3 or 4 non-missing data points and 3 or 4 imputed data points. So this is the number of mood scores that we get per week, and it's similar for steps and sleep. One thing that you'll notice here is that we had this kind of partial mode at 0, and why do we have a larger percentage of weeks with no mood scores at all? And that's because of kind of dropout. There's basically a small number of interns that just stop entering mood scores completely. So after maybe like October, they just don't enter any more mood scores, and that causes there basically to be a lot of weeks with no measurements. Okay, so that's the missingness. How are we going to solve this missingness? So we still want to get some information and do some analysis on this data. We're going to probably use the most common missingness technique, and that's multiple imputation. So we're going to impute at the daily level their missing data, and then eventually take averages at the weekly level. I'm going to talk about the imputation algorithm that we used. Like I said, it's kind of heuristic, but kind of give an idea of like the core ideas behind this imputation algorithm. And yeah, I'm happy to talk more offline too about this. So the first key idea behind our imputation algorithm is that we impute sequentially. So we only use someone's past data to impute their data today. So on day T, for example, we only use their history, so all data collected before day T, to impute data on day T. That's because our data is longitudinal data, so it's measured over time, and so it kind of preserves the time ordering. It also prevents you from biasing your causal estimates, so we're not going to be using future treatment or things affected by future treatment to impute on past data. So it makes us causally sound. So that's the first big component of our imputation technique, is that on day 1, we use all the baseline data to impute on day 1. And then on day 2, we use all the day 1 stuff and all your baseline data to impute on day 2. And we kind of just step forward in time like that. You'll see that there's like a little H hat here, which is like a history hat, because we're actually using not just the non-missing data, but we're also going to be using the imputed data from day 1 to impute on day 2. But it still preserves the time ordering, because this data is only imputed based off of baseline data. So that's the first component. So every day I'm going to impute using that history. And now within the day, what do I do? The second key component of our imputation algorithm is something that is commonly done in randomized control trials, and that's you don't impute all of the cohort together, the participants together. You actually separate the treatment groups and impute them separately. So I would impute, so on each day I have 7 different treatment groups. I have people who got the mood message that day, people who are in a mood week but didn't get any message, people who got an activity message, people who are in activity week but didn't get any message, sleep, and then also people who are just in a no message week at all. So I have 7 kind of treatment categories, and I'm going to impute them separately. What's the main advantage and why do they do this in RCTs and why am I doing this here? It basically prevents you from having to model the treatment effect. So if I imputed all of these together to keep my treatment effect within the data, I would have to somehow in my imputation model that how these groups differ from one another. I have to model that. I would have to basically model the treatment effect. I don't want to do that. I don't want my treatment effect estimation to be dependent on that model. So I'm just going to impute them separately and let the treatment effect kind of appear naturally from that separate imputation. Right. So that's the second key component. Is a separation of the treatment groups. So I have people who got activity or an activity week but didn't get a message. I have some missing, some non-missing. I'm going to use the history from the imputed history of this group to impute their data for that day. And then this kind of got messed up, but then I'm going to basically do that for all the 7 different groups and then combine them and combine them with the old history, my new imputed data set for that day, and then I now have my history for the next day that I'm going to use to impute for day t+1. You'll notice a couple different things. One thing is that you'll notice that I'm not sharing information over time, so I'm actually imputing each day separately, and I'm not looking at how someone's patterns progress over time to impute in their future. So I'm basically running a separate imputation for each day separately. So I'm not doing any sharing information over time. I'm sharing information across the people within the same treatment group. So that's how I learn how to impute, is based off of people in that treatment group. Yeah, so that's the imputation, kind of the main ideas behind the imputation algorithm that I'm running. And then the last key component is that I'm doing multiple imputation as opposed to just a single imputation. So once I do this for all these days, I now have a fully imputed data set, but then I just restart it and do it all over again. So I actually repeat it m times. The reason why multiple imputation is advantageous over single imputation is it's more robust to different assumptions about the data. So like, for example, in multiple imputation, you can assume missing at random instead of missing completely at random, if you're familiar with missing data techniques. And so it's kind of a more robust imputation as you do it several times and then you combine across those different imputations. So yeah. Yeah, that's a good question. I say impute with history. And I impute, but my history is like super high dimensional and super long, right? Because like on day 100, it's a 99 days worth of data. It's their like daily, or it's even minute level sleep, activity, mood, plus baseline data. So we did some prediction stuff Jenka kind of talked about yesterday, where we tried to predict mood, activity, and sleep on the 2017 cohort. And we found basically the biggest predictors of mood, activity, and sleep, and those are like your previous day's mood, previous day's sleep, previous day activity, your previous weekly average mood, weekly average sleep, weekly average step count, all the different baseline characteristics like their sex, their pre-internship mood, activity, and sleep. Those were kind of the biggest things. So like a couple days into the past data plus baseline data. Okay. And so this slide here is kind of about some concerns. I did this imputation, and I did something, but I still had some concerns and some kind of bigger level questions for imputing generally in micro-randomized trials. One is about the separation of treatment groups versus sample size. So you'll see like I can separate this into 7 groups because I have 1,600 people at each day. So I can separate 1,600 divided by 7 is I have around 200 people per group, which is enough, a sample size that's large enough to impute. But some of these micro-randomized trials have only 30 people. So let's say I have 30 people and I'm separating into treatment groups. Let's say I have 3 treatment groups. That's only 10 people I'm using on a given day to impute for that group. And that's not nearly large enough to be able to do some kind of stable imputation. So figuring out basically how do you do this separation when the sample size is small is key. I think also this idea, I think something related to that is how do you share information over time? So right now I'm just, like I said, imputing each day separately, but how do I use kind of their their patterns in their mood, activity, and sleep in the past to inform how to impute on day T. So figuring out, that would kind of like increase our sample size of some sort. So if I can somehow use past data and its patterns to impute on day T, that would be useful. And then this kind of also related this idea of like a flexible imputation versus a stable imputation. So something that is true in like missing data literature is that you want your imputation model to be more flexible than your analysis model, because basically if you didn't encode something into your imputation model, you're never going to be able to discover it when you do the analysis. So you want your imputation model to be extremely flexible, and then later when you do the analysis, you can do kind of a more concentrated model. The issue is, right, with kind of related to your question about the covariates I used, I mean, I could have an extremely flexible model. I could throw like, I mean, I could throw thousands of covariates into how I impute on each day. But if I do that, first off, I might not even be able to impute because my number of covariates might be much larger than my sample size. But even if it was, let's say I had 200 people and I had 100 covariates, that imputation is going to be very unstable. So my variance in my imputation is going to be super large. And when I do that, I'm going to kind of wash out all my effects. So how do you trade off? I guess it's kind of like a bias variance trade-off. How do you trade off like having a flexible imputation model while also making sure that it's stable and not too variable? Yeah, so that's a good question. So there are some people, like I said, who just drop off after October. I've included them all in my analysis that I'll do and I'll show the results for, but we have done sensitivity analysis where we drop like the people with X% or more missing, and we vary X from like 50 to 90, and we see that the results stay pretty consistent. Yeah, so that's a good question. Right, okay. Cool. Okay. And so now I'm going to present some analysis and the results of the trial. Probably the most interesting part of this talk, I think. To do the analysis for the micro-randomized trial, we use ideas from this paper, the Assessing Time-Varying Causal Effect Moderation in Mobile Health, which basically gives us the analysis technique that we want exactly. It's a weighted and centering approach. And the reason why you do the weighting and centering is because it's kind of more robust to modeling, different modeling assumptions. So you only need to model correctly the treatment part of the model, and you don't have to, the control covariates that you use that aren't interactive with treatment, you don't have to model that correctly, and your inference is still valid. It provides robust standard errors, and then to account for the multiple imputation that we did, we just do the common Rubin's rules, which gives you a way of kind of averaging over all the imputed data sets and their results, and how do you calculate the variability due to imputation and account for that. So this is kind of the most common way to analyze multiple imputed data set. Okay, so that's the analysis that we did, or analysis techniques. Now, what are the results of the trial? I'm going to start off, it's going to be kind of dismal and sad, especially when you put a lot of effort into a trial like this, but then Right. But there is hope, and there are some pretty interesting results eventually. So bear with me. Don't get too discouraged. All right. So the first result is about this long-term mental health outcome, the patient health questionnaire, measured at baseline compared to the first quarter, which is 3 months into this trial. The red is the message group, and the green is the no message group. And you'll see basically that there is no big difference at baseline, which is what you hope for because it's a randomized trial and we haven't given any intervention at this point. But after they've gotten the intervention, the message group doesn't really look different from the no message group. You'll see the increase in patient health questionnaire scores, which a higher patient health questionnaire score means more depressed, roughly. So increase in bad outcomes, but the increase is the same between the two groups. Okay, dismal result number 1. Second result is about how do messages affect your mood, activity, and sleep at the weekly level. So I get a week worth of messages. How does my mood that week compare to the weeks where I get no messages? So this is general, which means any type of message. mood, activity, or sleep. And then I'll talk about the specific categories of messages eventually. But general messages effect on your mood. We see a significant negative effect of messages on your mood. So we're seeing that actually compared to weeks with no messages, a week of general messages decreases your mood by about 0.03. That's a very small effect size, by the way, because the mood score, remember, is on a scale from 1 to 10. So that means, it would take about 30 messages in order for it to decrease by 1. But it's significant nonetheless because of our large sample size. Yeah.
So this, everyone has received the outcome.
Right.
So in this analysis, your outcome is
Like, so this is on average over the entire study, right? So yeah, for the whole sample. Yeah. It's sort of like a main effect. If you think about the micro-random trial as like a factorial design over time, it's like a main effect over, yeah, so it's just saying on average over all the weeks, over all the people, general messages decrease your mood by 0.03 compared to no message. Yeah. Okay, and then, right, so then we look at mood messages specifically and their effect on mood, and we see again the similar decrease, not significant because we reduced our sample size because we're only looking at mood messages, but still signs of a negative effect. Now the question is, how do activity messages, a week of activity messages, affect your activity, your weekly level activity compared to no message? So yay, we actually see a positive effect, though non-significant. We do see that there is some evidence of an increase in activity from getting these messages. What does this 0.088 actually mean? It means like a 123 step increase in average daily activity per week. So we take an average over the week of their daily activity, and that goes up by 123.
People actually run experiments like know that this is like the way what is the way we're thinking stuff is actually different. Isn't it obvious this stuff should help? Or actually it looks like what there's an effect. Then you say, well, it seems clear that mood messages should increase outcomes. Actually, that's what we learned. It looks like it might actually be purely negative. So that's how I think it's interesting results.
Right.
I don't remember it differently, but these are when someone thinks something's obvious and it should have this effect.
Yeah.
We learned something.
Right. Yeah, I think when I write the paper, I'm not going to be like, preempt them, be like, this is a non-interesting paper, please don't read further. I think I agree with the way you framed it of like, oh, yeah, we actually didn't find an effect in some things, but that is of interest because,
information gain is high. It's like my hypothesis is something.
Right.
Actually, I have a question. The decrease in general and mood.
Yeah.
Is it good thing or bad? Because I don't know how your mood score.
It's
higher score is good mood?
Yeah.
Oh, okay.
Yeah, it's like scale to 1 to 10, 10 being high, 1 being low.
So you want people that high score?
Yeah. Exactly. Yeah.
Does you see messages affect whether or not the report their outcomes?
Did we look into that? Whether or not they report? Yeah, we looked into that, and we didn't see big effects actually on, getting messages affecting their missingness. Okay. Then we look at sleep data, or sleep messages on sleep data. So how does a week's worth of sleep messages affect your weekly average sleep? And we see that, again, some evidence of a positive effect, but again, pretty small, about 2 minutes of sleep on average on the daily level of sleep. So this happens, and this is maybe less interesting if we're informing science, or maybe it is interesting. But I think the most interesting stuff comes in the moderators analysis, which is, again, a moderator is a variable that's collected prior to delivery of intervention, and it moderates or changes the efficacy of that intervention. So, like, for example, previous week's mood might be a moderator of mood messages if mood messages work better for people who had low sleep previously and work badly for people who had high sleep previously. So we're actually going to look at, like, based off of your previous week's data, how do these different interventions affect you differently? And if we find a good moderator or something that is a significant moderator, that informs, again, how to tailor the messages. So if, let's say, low mood leads to good, high, like, positive effects, and high mood leads to negative effects, and that would tell you maybe we only want to send messages to people who had low mood previously, not people with high mood. So Right. So though we have this negative effect overall on mood of messages generally, we do see that there is a significant negative moderation of these messages with your outcome on at the weekly mood level. So what does this graph show you? This basically shows you how the treatment effect changes based off of your previous week's average mood. And all of this, again, is compared to no message. So if last week I had an average mood of 5, let's say, and I got mood messages this week, I would actually have an increase in mood by about 0.1 compared to no messages. Similarly, if I had a really, really low mood week last week, around 2.5, then I would have an effect of about 0.23 on my next week's average daily mood compared to no messages. And again, when my mood is actually really high, you see this negative effect here. So if my mood is around, let's say, 9, then the effect of getting a week's worth of mood messages now has a negative effect on my weekly mood compared to no messages. So this is a negative moderation of your previous week's mood, which again means that for low previous week's mood, messages do well. For high previous week's mood, messages do poorly. The reason why we get the overall negative effect is because most of the average weekly mood scores are around like 7.5 or 8 actually, so they're in this area. But for people with really low mood, we do see some kind of positive effect. So that's hopeful that maybe if we change who we send messages to, or we only send messages to people with low mood, we can actually, these messages can have a positive effect.
I think this is because it runs very high mood. So next week you have bad mood, right? Because of circumstances. There are various confounds. Regression to the mean or something like that. So in other words, if I have very, very high good mood, I don't need your help.
Right.
If you help me, it really probably doesn't matter because next week I have bad mood, right? Because of other things happen.
Right.
So I think actually, and your story probably knows that I really need some boost.
Yeah.
So you give me the boost at the right time.
Exactly.
Otherwise, I don't need the boosting.
Yeah, exactly. I mean, the messages are intended to be somewhat therapeutic, right? So we want them to affect people with the low mood, and we don't really care about how they affect people with high mood, or we do care if they actually have if they bring them down, but.
But I think those high is really because there are other circumstances.
Right.
Because mood is itself without this is time variable.
Right.
Because there are other external factors.
Right. Right. And I just want to clarify, this is all treatment effects compared to no messages. So this, let's say at like 9, this is the comparison. If I look at all the people with a previous mood of 9, and I send half of them mood messages and I send half of them non-mood messages, the people with the mood messages will have a decrease in mood by about -0.1 compared to the people with no messages. So it's not just purely, I guess, regression to the mean in the sense of like, it's not just, obviously if they had high mood last week, the next week their mood's going to be a little bit lower. It's not just that. It's looking at the comparison to no message. So this is like, they actually drop even more in their next week's mood compared to people with no message. So, yeah, but I agree with what you said of this is probably the most interesting part because that's the people that we want to affect.
Also, I think there must be some side effects because you have to say you have the data from different hospitals.
Right.
So some hospitals are easier.
Right.
And others are more difficult.
Right.
So I think there are a lot of confounds.
Yeah, and this is I would say on average over all of those different hospitals over the whole sample.
Probably we sort of look at do some subgroup analysis.
Sure.
Then I think your effect will be much more for that.
For certain groups, right? Yeah, right.
So you said that I know it's a treatment effect, so it's unlike regression to mean.
Right.
But still, do you think there's something that could be going on with like missing data or something that could lead to this regression?
I mean, yeah, I was worried about this too, but so what I did as a sensitivity analysis is I actually I did this hard subgrouping, threshold subgrouping, where I looked at just people, let's say with 8, 9, or 10 of their previous week's mood, and I look at the treatment effect on them, and I do see the treatment effect is negative. And then I looked at people with their previous week's mood being around like 3 to 6, and I looked at the treatment, and I get rid of everybody else, and I look at the treatment effect on them, and I see that there is a positive effect. It's like, I have all the way back, this one. So this would be mood messages, these would be sleep messages, these activity messages. So there's a whole bucket of each of these groups, but this is the idea. Right, so I think one mechanism that we've come up with is that these messages are sort of tailored to people that have low mood of sorts. So they're supposed to be therapeutic, like, oh, they're kind of like, hope you get better sort of things. I'm not framing this correctly because I'm not a behavioral scientist, but they're like trying to improve their mood, which we think could be frustrating. If someone has a high mood and you say like, hey, like improve your mood, they're like, why do I need to improve my mood? I'm super happy right now. So right, and so maybe it could actually decrease their mood. But for the people with low mood, the therapeutic messages actually do have evidence of helping them. So
That's a very nice finding because most people are curious about this extraordinary effects are very rare. Most people like 10 times rarer. It's like, oh, it's a drug like that.
right.
But you actually have to find that's super hard.
Right. Yeah, I think the reason why we can do it is because our sample size is so large. If we only had 30 people, these moderator effects are really hard to power for, I think. Yeah. 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 I mean, the median is, like I said, around like 7.5 to maybe 7.7 or something. I would say the first quartile, if I remember correctly, is around 5. So this is only like 25% of your data is here. Maybe 25% is here, roughly. This is just what I kind of remember. Yeah. 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 I think doing some type of like bootstrap confidence interval or something around this would be useful. But this p-value here is just for an effect of this slope, right, overall. But I don't have like confidence bounds at each. Because if you did that, you would see, because of the sample size, would be a really large confidence bound. But yeah. How? You include it as like a moderator in your model, so I can write down the model maybe. Sorry, no. This is just a horizontal line for reference.
Oh, so you actually just aligned.
Yeah. The red line is comparing message to no message. Yeah. Does that make sense? Okay. Thank you, everyone, for the questions. It's helpful for me, too. Okay. And then, so we basically separated this into the 3 different categories of messages, and we actually see that generally across all the different categories, we have a similar type of moderator effect on mood. So all the messages generally affect people with low mood better than they affect people with high mood, and they have negative effects for people with high mood. And we kind of saw this across the board, actually. The mood messages, when your outcome is mood, the mood messages behave similarly to the activity and sleep messages. So it's kind of interesting. Okay, and then I looked at the similar thing for activity messages. So how does previous activity moderate the effect of activity messages? So maybe people with low activity like activity messages, people with high activity don't. And that's exactly what we find here, again, with this negative moderation, where people with low activity get some type of increase in their step count from getting activity messages compared to no message. And people with high activity, it starts to dip negative. And again, this is significant. This is a linear slope on the cube root scale, but this is the actual cube root effect, I guess, or effect on the actual step count scale. You'll see basically kind of like with someone that had previous week's average step count of around 6,000, we get an increase by about 100 and maybe 120 by getting an average daily step count. So that's basically the daily step count by getting a message versus getting activity messages versus getting no message. And then similarly, if someone had step count around 11,000, then we would see a decrease by about 50 in their daily average step count by getting activity messages versus no message. So again, we see that these messages are sort of therapeutic or helping people with low. Yeah.
Why did you choose to use a cube root and the other?
Yeah, I mean, it's the one that makes it most bell-shaped, I guess. Yeah. So yeah, we looked at kind of like, yeah, x to the alpha with alpha varying, and then cube root was the best. And then for sleep, so yeah, so again, we look at the moderation effect of sleep messages. So maybe sleep messages work better for people with low sleep and work worse for people with high sleep. And again, we find this negative moderation of this graph. I switched the scales a little bit, but it makes it easier to read, I think. So if someone had a previous week's average daily sleep count of 6 hours, then getting sleep messages would increase their daily sleep minutes, not hours, minutes by about, let's say, 4. So if you had 6 hours in the previous week, you get a 4-minute increase. If you had 8.5 hours of sleep on average in the previous week, then getting sleep messages actually decrease your sleep by about 6-7 minutes. Right, so again, we see this negative moderation of messages. And I think overall, this negative moderation that we find across the board, it indicates that we should be tailoring these messages or varying when we send messages. Maybe we don't send messages to people with high sleep or high activity or high mood, or we change what the message actually says when they have high activity, high mood, or high sleep. I know I'm almost out of time, but I compared life insights to tips. There's really nothing that interesting. This is with outcomes being activity, mood, or sleep. We see definitely no difference between life insights or tips for mood messages. For activity, we see that maybe, and for activity and sleep, we see that tips maybe are slightly better, which we kind of explain through the fact that maybe they don't want their information about their low sleep or their low activity because they know that they're in a stressful time. They know they're not getting as much sleep as normal. So maybe it's better just to give general advice and not data-driven advice. But those effects aren't significant at all, but just kind of interesting to look at. Yeah, so these are the main conclusions. We do see main effects close to significant, significant for the general messages, but the effect sizes are quite small. The moderator effects, which I think are most interesting, indicate that the messages should be tailored. There's not a big difference between life insights and tips, and there's not a big change on the long-term mental health. For the 29, so this trial gets run every year, so it's going to be run again starting July of 2019, hopefully with a bigger cohort. And we're doing some changes to basically improve our main effects. One is that we're actually including a new category of message, which is about their circadian phase, which is kind of interesting and novel. So there's some people on the team who are interested in circadian phase and how circadian phase relates to sleep quality and depression. And so we want to maybe start sending messages about their circadian phase and their alignment with their circadian phase. So if I'm sleeping in line with my circadian phase, my sleep quality will be better versus if I'm sleeping starting at 8 a.m. when the sun's up, then my alignment will be poor and my sleep quality will be worse. We're going to now have message tailoring based off of that moderator effect. So we're going to tailor this time actually the wording of the messages. We're not going to not send messages to people based off their past data, but we're just going to change the wording. So people with high mood or high activity or high sleep are going to now get differently worded messages, not therapeutic type messages, but maybe positive reinforcing messages, or even just a message like a fun fact or something. So that's a difference, but that's based off of this moderator analysis that I discussed. We're eliminating the weekly level randomization because The behavioral scientist is now more interested in the daily level effects and short-term effects and less interested in these kind of weekly level effects. So we actually are now doing it at the daily level. And the last thing we're doing, which we didn't have this year, is we're actually going to obtain their work schedule data. So we don't know what days they're on work and off work. And so we're going to see maybe like messages, kind of like what Susan was talking about with heart steps, of like certain messages doing better on weekdays versus weekends. Unfortunately, with the interns, their weekday and weekend is not Monday through Friday and then Saturday, Sunday. It's a variable all over the place, but we'll get that information now and see how these messages effects change based off of their work schedule. And here's some future work. The multiple imputation scheme, I'd like to think about more, think about its causal validity, think about how to make it stable, low variance, talk about potentially extending methods to ordinal data, because our outcome of mood is actually 1 to 10 ordinal. So I think it'd be interesting, though I think you can basically treat it as continuous, because if you look at the histogram of it, it is basically continuous, but I think if we wanted to be more precise, there could be advantages to treating it as ordinal. And then also thinking about how to maybe potentially share information. We have years and years of data, and we'll have years and years of trial data every year, and so how to share information across these different trials and different years of data would be interesting. Okay, thanks, and references.
You say it's an ongoing study, so who funded
yeah, I mean that's above my knowledge level. I just get the data and get to play with it, which is fun. And design the trials and things. But I think Jenka might know more. But like NIH, he has a couple R01s or one R01 that funds it, and then he also gets funding through Michigan has this data science Midas.
So that's what I mentioned now.
Right.
Has some stocks.
Right.
So
I'm not sure.
So he has Michigan, Michigan. So that's why I was curious, because you said, of course, it's sent to the US, but I think Michigan itself, because it's
right. Yeah. I mean, I think Michigan, it does like they.
Of course, the selling point is you can improve hospital care, right? That's
right.
So I mean, you get better doctors.
Right. Right. Yeah, I think obviously there's lots of incentives to improve the sleep. I mean, there's studies about like basically some of these interns are going to work with like minimal hours of sleep, and it's like equivalent to almost being like drunk on the job, like equivalent type of neuro stuff going on. But yeah, so I think it's of interest broadly. I'm not sure the exact funding resources. I think like I don't have the website, but if you just Google intern health study. I'm in Michigan, yeah.
You haven't moved
no. Right. 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 Yeah, I think, yes, some of this was initially started from some of those conversations, and then Jenka and I started to take it over, when she moved. And so, yeah, we designed everything and did all the analysis. But yeah, I think some of the grants maybe were originally proposed with those conversations. Yeah.
At Stanford, we have a neuroscience institute. So that's where you get that.
I see.
And that's basic information foundation. Rather than the other, it's probably not that high.
Right.
You
Yeah.
You observe an intuition, like for example, if the subject is randomized for 1 week, and for the next week, then they have a, let's say, like in the second week.
We didn't look at like the two like mood versus like nothing, but we looked at just kind of mood effects throughout the whole study, and we do see some general habituation that often comes up in mobile health studies of the message effects are strongest at the beginning of the study compared to later in the study. Yeah. But I didn't look at like the sequence of 2 weeks in a row.
So, as about the main effect analysis, you should compare the means of the two groups with the data set or
Yeah, it's like a regression type thing. So we have like control covariates that we include. It's like an estimating equation type approach from that JASA paper I showed. But basically, you have control covariates that help reduce your variance, and then you have like a coefficient for the treatment effect, and then you look at the.
My understanding of missing data is that if you did it expression-based analysis, actually is better under NER. Right? I just wonder whether the multiple imputation will help you control. Removing some of the assumptions that you need
I mean, so yeah, the multiple imputation allows you to work under like the assumption of missing at random instead of missing completely at random, which basically your missingness is allowed to depend on observed covariates versus just not depend on anything at all. But they're obviously like it's not the most relaxed assumption. Like missing not at random could be where your missingness depends on things that you don't observe, but I think missing at random tends to be like the best you can do, and I think it's better than just like another example. I could do some kind of like mean imputation, or I could do like a single imputation, and those would work under the assumption of missing completely at random. So it's more relaxed assumptions than that. And do treatment effect, just do the analysis on the observed. You just draw the complete case analysis. I think that would definitely be assuming missing completely at random, where your missingness doesn't depend on anything at all. Basically, it's like someone took your data set and just flipped coins and chose which points to remove. But I think that assumption would is not true. Like I think, there are things. I mean, I don't know whether or not it's missing not at random versus missing completely at random, but I think there are patterns in the missingness that should be controlled for, I guess. Right. Interesting. Right. Yeah, that's interesting. So like, even though we reduced their sleep, it's a good thing for people over 8 that we had a negative effect. Oh, yeah. Right. They're like, no, I should wake up earlier. Yeah. I see. Right. Right. I think that's interesting. The only thing I would say is that I know this population on average does tend to not get a lot of sleep, so I would say most people would just be okay with increasing. I see. Right. Yeah, that's interesting. Or I mean, another thing that's interesting is like depression. Like, there's like bimodal distributions of sleep for people that are depressed. People who are depressed and don't get a lot of sleep at all, like they can't sleep at night. And then there's people who are depressed who sleep all the time, like 12 to 13 hours or something. And so, right, yeah. Right. Mm-hmm. With a really large number. I mean, I'm not super familiar. A lot of times when I read like missing data papers, they usually say that, you would definitely want at least like 50% of your data to be there. And I don't see a lot of stuff with like, oh, when you're missing this, let's say it's like, there's only 30% observed, then what do you do? I don't know. It seems like you're pretty much out of luck a lot of times, but I do think it's interesting because, I mean, I think some people move in the direction of like, I have a mobile health app, right? I can just release it to everybody, and I can have thousands and thousands of people in my study, but I'm going to incur a lot of missingness. Can I still gain some kind of information from that data? And I do think generally it's important to think about, I'm not sure what to do though, when you have such a large percentage of missingness. But I think it's interesting. Yeah. I think multiple testing ideas of just, I just want to, because this would be a lot more. Yeah, I think these were the analyses that were like, if we rank ordered them, these were the top ones, but I mean, we did the analysis, but these were the ones that we focused on presenting and the ones that we were most interested in, but yeah, I think that's the main concern. Yeah.
So now in this case, I'm going to say I think about that. Actually, what is the algorithm? So maybe there are two different versions of the experience they will have in that environment. It's not, I don't have the answer to this, but it's one of it's possibly the all versions of it.
Yeah, I mean, I think, like we did, for example, they had this qualitative survey at the end where the interns ranked like their favorite and least favorite messages, and we looked at the effects of like different types of like even more subcategories of messages or subcategories of sequences of messages and stuff. But I think, I don't know, I mean, basically once you start splitting things up, your sample size is reduced, and you get non-zero effects, but maybe a lot of non-significant effects. So I think, it's a trade-off of how much you want to separate things and reduce your sample size. And people were interested, like Srijan was interested in like looking at very like different groups of people or trying to like, group people together based off of like how their treatment effects are affecting them differently. But I just think the signal in the data is not large enough to be able to do that meaningfully, I guess. Yeah, thanks. Thank you.